say that we wanted to do a conversion. This is pretty simple. I'm starting with simple on purpose so that we can get the concept. If I don't explain this to you, I feel like it's just a bunch of steps that you go through but you don't really understand. So I'm going to explain to you how to do it, but at the same time I want to explain to you mathematically why you can do it. And that'll keep you from messing up. So anyway, let's say that I had 3.2 yards and I wanted to go and convert that to inches. We're going to start real simple. Okay? Talk with your group and come up with 2 things that you as a human being probably already know that you would need to know to be able to solve this problem. Okay, so talk to your group. Go ahead. 2 things, not 1 thing, 2 things. Alright, Justin, tell me one of the things. Okay, well, how about we go a little bit simpler than that? How many inches are in a feet? And do you know how many inches are in a foot? Cool, so 12 inches equals 1 foot. I feel okay about that. What is one other piece of information that we would need to know to be able to do this? Christy? Huh? So if I knew how many inches were in a foot, would that help me to go from yards to feet? Like what else? What other piece of information do I need to know? Somebody at your table maybe can.
Feet to yards.
Okay, and so how many?
3 feet.
Okay, so there are 3 feet in 1 yard. There, that makes me feel better. So when I'm looking at this, in math, if I were to say there are 12 inches per foot, or even on your car when you're driving, if it says you're going 60 miles per hour, in math there's 4 operations. There's addition, subtraction, multiplication, and division. So talk to your people and try to figure out which one of those is per. Ready, go.
Well, think about it, 60 miles per hour. You're going 60 miles per hour. You're going 60 miles.
This is good words, problem solving, making you better people right now.
No, maybe.
All right, so Autumn, what do you think?
I thought it was multiplication, but it seems like it's got like a mixture of multiplication.
All right, so she says multiplication or division. Christian, what do you think?
Division.
Okay, so when you're in your car and it has 50 miles per hour, it really means you're going 50 miles in an hour. So anytime you can say the word in a, per, that means you're divided. That's exactly what that means. Okay, so per means divide. And actually, just because I won't be able to sleep tonight if I don't tell you this, of means multiply. Of means multiply, per means divide. That is just good information for you to know as like a I'm going to college person. So anyway, if 12 inches per foot, per means divide, that's dividing, right? A fraction is dividing. Is that okay? Well, is it okay if I say 1 foot per 12 inches? That also true and good? Okay, cool. So that equals that is also can be written as a like a ratio, and I'm going to write that as a fraction. Fractions are the thing. I like fractions, right? Everybody hates me. All right, so talk with your group and come up with 2 fractions that I can write for 3 inches in a yard or equals a yard. To come up with 2 fractions I can write for that. 3 feet in a yard. Or 3. So I need 2 fractions for this. That was quick. All right, so give me one of your fractions, Thomas.
3/1.
And last lesson time. The whole purpose of this activity is we're gonna be converting units, right? So if you give me 3/1, I don't know if that's 3 gorillas per like 1 banana. I don't know what that is. So why don't you try that? Why don't you back up and pump one more time?
3 feet over 1 yard.
Thank you. And give me the other one since I'm talking to you.
1 yard over 3 feet.
Perfect. Now these little fractions, I'm gonna make these one color up here. These, and I'll give this a different color just because I want to. And these fractions are called unit conversions. So, or conversion factors. Conversion factors. So I have 4 conversion factors on my board. In math class, what's factor mean? Talk amongst your people. What's factor mean? Y'all starting to doubt your life of what you've been doing for the last 7 years. Is that happening? What does factor mean?
Yeah, like if you have like an equation, you factor out 2
If you were factoring out an equation, what would you do? All right, Lindsay, what would? Yeah, you're simplifying it, and so when you factor something, like if you had, I see where you're going with that. Like if you had, and it said to factor that, what would you do? What mathematical operation would that be?
Distribute.
And then I would go 3 blank x. What would that blank be? 3. Add, subtract, multiply, divide. Multiply. Factor, like the least common factor, right? Greatest common factor. All that. Right, yeah. As soon as I said it, I was like, that's right. But factor it means to multiply. Okay? So these things, but the whole purpose is we're trying to convert, right? And these things are going to be things we're multiplying by. I mean, you I'm feeling it so far. Doing okay? Haven't done anything yet, really. Okay, so one more question, and then I'm going to work it out. If I were to give this fraction or conversion factor, this conversion factor, this conversion factor, this conversion factor, if I was wanting to assign that an integer, a counting number, if I were to divide this out, because this is really a division problem, what number would all these be equal to? What integer, what counting number would all these really be equal to? So talk amongst your little friends.
Yeah, it's 1 times 12 times 5 or 4 times 1.
Allie, what you think? If I were to somehow be able to divide those.
Oh, I said 1.
Oh, 1, great. And do you know lots 1? Anything divided by itself is, and 12 is the same as 1 foot. 1 foot is the same as 12 inches. 3 feet is 1 yard. So the same, you're dividing something by itself, so they're really equal to 1. So far, we can see that we can make fractions called conversion factors out of things that are equal, or things that say per or NA. And then that these fractions, when you start thinking about them, they should equal 1. So, is that all right? Everything cool? Okay, well, let's go ahead and solve this. I'm going to start with 3.2 yards. And I'm going to write it over 1. And we'll get into that a little bit more later. I'm actually going to erase this whole board because I'm going to write everything. So, I'm going to inches. Math class, you can kind of cancel kind of diagonally or something on top of each other. You know how that's a thing in math? Is that ringing a bell? Okay, so if I'm trying to go to inches and I want yards to kind of I'm trying to convert away yards. I'm trying to make it go away through conversions. What do you think? Just maybe. I want to put on the next, or excuse me, the bottom of this next fraction. Just take a guess, Jonathan. What unit do I want down here?
Yards.
Sure. And so I had two choices. We had yards to feet and feet to inches. And so we had 1 yard, 3 feet. Right? Now, if the question was asking me to go to inches, am I done? No. Okay. So what needs to go on the bottom of the next fraction? Lindsay? Yes. So 1 foot is 12 inches. Now, this is like the key to life. This will work forever in any class, okay? When you have what you wanted in this top right-hand corner, I just circle it. And I'm like, yeah. And then I'll go back, and I'll make sure my stuff cancels. Because in AP Chem, you don't get a calculator. So you're about to do a lot of long multiplication and division without knowing if you're right or not. Because this is a skill for both of those classes. So anyway, now I can multiply across the top. And at this point, I'm just doing math, and you can use a calculator. So 3.2 times 3 times 12. And I get 115.2 inches. Look at me in the face. The point of this is converting units. You need to have a unit on every single fraction because it'll keep you from messing up. And then on your answers, because that was the point. I don't care if you give me 115.2 because I don't know what you're talking about. Like I said, you know, you can talk about gorillas and bananas. I don't know. So anyway, looking at this, these are called conversion factors, right? These have infinite significant figures. So I'm really always going to be limited by that thing I started with. And so I can have 2 significant figures because I'm multiplying, and that's the rule for multiplying. Notice the bottom, I just had 1. So it's really this, but that's still going to give me 115.2. So 2 Sig Figs is 120 inches. And then make sure your answer makes sense. Does it make sense that if I had 3 yards, that I would have 115 inches? It wouldn't make sense if I had, you know, 0.0000006 inches. Like, that's the thing. People do that, and they're like, oh, I got 19,000. That makes sense. No, 3 meters 6 ain't. Nope, that's not a thing. So, there. Now, I'm going to move over to your paper, and I'm going to show you how to do this with some little problems. Please stay with me. Stay with me, sweet children. I know. I hear you. I promise I'm trying to help you. So what I'm going to do is when I'm reading these questions, I'm going to look for what needs to go in that first, at the beginning. And so let me kind of give you a hint for that. The first number that goes over 1 at the beginning, I'm going to look for something that doesn't have a friend, is not equal to anything. Okay? And so if I read this first one, how many miles will a person run during a 10-kilometer race? So I'm kind of looking for where to start. And I'm looking for something that, you know, doesn't have a friend. See how this number isn't equal to anything? So I'm going to put a line under it. So 10 kilometers. Then I'm going, you know how in that top right-hand corner I circled my unit and I was feeling good about it? I'm going to circle what they want me to solve for. So I'm going to circle miles, and I know miles needs to go on that top right-hand corner. Then, in between all this, I'm going to have some conversion factors, those things that are equal that I'm going to use to multiply. And so I'm going to come up here, and I know I'm going from kilometers to miles, and I'm just going to kind of look through here and see what would help me. So I'm looking. Look, here's one for miles to kilometers. Now, sometimes you might need 2. Sometimes you might need 3. That's okay. We're going to start with 1. And so here is my conversion factor. I can write this as 0.621 miles over 1 kilometer Or I can write it 1 kilometer over 0.621 miles. I can write it either way, upside down, doesn't matter. It's both 1. Something divided by itself, 1, don't matter. Switch it around. So anyway, I'm going to take the one I underlined, and I'm going to, crazy talk, I'm going to underline it. See how I did that? So you're kind of guiding yourself through this. I underlined the one that I was starting with, and so I'm starting with it, and I underline it, put it 1. You know, I'm just putting these things over 1 because it's going to help keep my fractions straight. It's just a kind of place-holding, you know, my numerator here. Now, I need this to work for me so that kilometers is on the bottom. So I have 1.0 kilometers. And that is 0.621 miles. Now, what did I have circled up here? And do I have it in the top right-hand corner? I always circle it, make sure my stuff cancels. So 10 times 0.621, if you can't do that in your head, we need to have a little talk, okay? 10 times 62 cents is $6.20. You see what I'm saying? So 6.21 miles. Now check my Sig Figs. How many Sig Figs does 10 have?
2.
Really? Does it have a decimal? So that would be 1. Because those end zeros are just, remember, we have to have a decimal. So anyway, really the answer is 6 miles. There we go. Okay. So, do y'all know why I can just pop out all these things and start multiplying by it? What's this equal to again, one more time? Is it okay to multiply things by 1? Does it stay the same? And sometimes in AP Chemistry, we might have 5, 6, 7 of these fractions. And everything's fine. I can do that all day long as every fraction equals 1. Because you can multiply things by 1 and don't change the value. That's the purpose. You see, I'm trying to explain to you kind of how this goes. So anyway, let's do the next one. The moon is 250,000 miles away. How many feet from Earth is it? So take a second on your own, and I want you to underline where I'm going to start. Kind of find something that's not paired with anything. I want you to circle what I'm looking for, and I want you to put a box around the conversion factor at the top we're going to be using to get there. Could be 1 conversion factor, I think it is, might be 2, later it'll be 2. Every fraction, every time. See, some of y'all go ahead and set it up. If you want to go ahead and set up and solve it, you can do that. I want to see a unit on every single number on your paper forever. Forever and ever and ever. I really need it. I mean it. Yes, sir? Hang on, let me come and talk to you. What you got? Oh, doing it with the little, that's fine. I need to see some of these. You can make those little lines.
Can which one is scientific notation?
You should, yeah, you probably should. I'm going to look at that. We'll work out. Start with something. We always start with, so you get to start with flip-flop. You're not wrong, but you're going to be sad later.
Okay, so it's better to write it.
Hello. So this one is definitely going to be helpful to, you know, at least finish up in scientific notation if you didn't start with it. So, you know, this is where I'm going to start. You always want to start with a fraction that has 1 on the bottom. You don't want to start with a conversion factor. What I mean to say is, don't start with one of these fractions that's equal to each other. You want to start with the one you underline. That was the purpose, okay? So I want to start with 250,000 miles over 1. And then the next fraction I'm going to be using, I need miles on the bottom. And I'm trying to go to feet. And if I look up here somewhere, it says 5,280. I just happen to know that.
They're
Left
one
side,
of the
third
first
column.
ones.
Oh, okay, cool. So that's the one I was using. So 1 mile, and I guess it's probably not plural, is 5,280 feet. And so, checking myself, making sure I have what I want. That was the circled one, was feet. And so if I go ahead and multiply this out, whoops, I get 1.32 billion, basically, or 132 and then a bunch of zeros. But I'm a big fan of scientific notation. You can count the zeros up if you want to. It ends up being, let me make sure I'm right.
Yeah.
Okay. It ends up being this ungodly awful number. And, I mean, I can count 1, 2, 3, 4, 5, 6, 7, 8, 9, and that's where I get the 9 from. The Sig Figs that I need here, though, they're actually just 2. So that's really where I'm going right there. That's 2 Sig Figs and feet. And there's my answer. Okay. Let's do the next one. Let's do the next one together. I'll let you get started on your own. Remember to underline where you're starting, circle the answer they're wanting you to go to, and put a box around the conversion factor. That box around the conversion factor is really helpful because here later, you're not going to be looking at that chart. It's going to be in the paragraph with the other stuff. So I'm trying to get you ready for harder things. So when you get, oh, okay. So how to like type in an exponent? Yours probably has a to the, this is cool. So like, well here's the, you should have a button or, I have a different kind of calculator. But you can go like, what's your number you want to do? 1.3? 1.3 times 10 to the, here it goes. Yeah, that's how you do it.
Thank you.
Cool.
I think on the Texas Instruments one, there's a dedicated button.
There is. Sure is. While y'all are working, I'm just gonna kind of work quietly up here. If you want to check as you go. Most of y'all are doing well. That looks like a Gaelic symbol or something. Wow. There we go. So how'd that one go? Feeling like experts? I wanted to do this one with you before I let you go be by yourself because someone asked me first period, they said, I thought the stuff on the bottom was always 1. No, that's not true. So you just want to multiply across the top and across the bottom and divide. And so you got 1 Sig Fig and 10,000, so 40 is your way to go. Do you feel comfortable? Start on number 4. Anything I need to explain before you go on? All right, go ahead and give that one a try then. And that'll be the last one we do today. So 40 only has 1 Sig Fig. So the 0 don't significant unless you have an exponent. That's okay. That first one go okay for you? 5.5 hours. Okay. The next one does need 2 fractions. Oops, I did that wrong. So I want to show you something. Hey, so look what I did. I noticed it before I even went on. Because before I move on, I make sure my stuff cancels. And immediately before I messed up, because I use my brain and I'm thinking through this whole process, do you see what I did here? See what's wrong with that? Yeah, they don't cancel. And you know what? If I didn't write my units, I wouldn't have caught myself. So you need to write your units every time. I need to flip that upside down. Yes, sir?
What if you just use the
3,600? That's fine.
No, instead of 330 minutes, because you know it's 330 minutes.
That's actually a really good idea. You could totally do that. Right. That's perfect. That's fine. I'm going to keep going with where I'm going, but yeah, that's a great idea. I always want to show you one with 2 steps, so, but no, you're right. You're right. Absolutely right. I want to show you something about this one. How many Sig Figs do I have to have? 2. Do you see the problem? If I write 20,000, how many does that have? If I write 19,800, how many does that have? You have no choice here other than to use scientific notation. Because that decimal makes that significant times 10 to the 4 seconds. How do you feel about that? Okay? Now, I don't want you to do any of this for homework. I don't think that's a nice thing to do because you just learned it 5 seconds ago. So take it home, enjoy a night. If you don't have anything, since you just had a test today,